and R5 will not, but I'm going to leave it up so that way you have access to it. All right. Anything else? I think we're good. All right, let's tackle R5. So R5 has two parts. The first part is quadratic and rational equations. This is going to feel like a repeat because you've done this before, but follow along with me anyway. So we got a quadratic equation. First off, I'm going to show you some notation. You're going to see it down here. I've got first line of this definition says let A, B, and C represent real numbers. I'm going to shorten that using mathematical notation. A, B, and C are elements of the real numbers. That is the same thing as what is written here. So let A, B, and C be real numbers. Okay? You'll see down here in the zero product, I use that notation. I want you to get used to it. So those are real numbers. That just means they're not complex. Okay? Where A is not zero. Well, if A was zero, look at this quadratic equation. If that's zero, that whole term goes away, and now I have a linear equation. So that's why we have to state for the record that A cannot be zero. So if I have real numbers A, B, and C, a quadratic equation in the variable x is an equation of the form ax squared plus bx plus c equals 0. All right. What we're going to do in this section is we're going to learn to use the zero product property, the square root method, the quadratic equation, and completing the square to solve quadratic equations. All right. So let's break down what does this mean? Okay, or what are we doing here? Well, I need to introduce the property on the left first. It's called the zero product property. You'll hear me say zero product principle as well because I've heard it called both. And it's a really basic concept. It says let m and n be real numbers. If m times n is equal to 0, then m equals 0 or n equals 0. Also, both could be 0, but this is what we want out of it. If two things multiply to 0, one of them has to be 0. This is the only number that has this feature, right? If two things multiply to give you 2, you're not guaranteed one of them is anything, right? Because I can get 1 times 2. I can get 4 times 1/2. I can get 8 times 1/3. There's no guarantee what one of those two numbers is. This only works for 0. And the reason it works for 0 is because anything times 0 is 0. And if you multiply two numbers that are non-zero, you will never get 0 as the product. So it's a special feature of 0. So how am I going to use this to my advantage? Well, I'm going to work my way to a problem where I have two things multiplying to give me 0 and then use it. So let's solve this equation down below it. 3n times quantity n plus 2 is equal to 4 minus 5n. Okay, so I'm going to distribute on the left. 3n times n is 3n squared. 3n times 2 is 6n. The right-hand side has no math to do. This is a quadratic. No common terms on the left to add together, no common terms on the right to add together. So I don't need to combine like terms yet. I combine like terms with these two, can't combine like terms with the two on the right. So now it's a quadratic equation. I need one side to be 0. So when I'm dealing with quadratic equation, I'm going to get everything on one side. So that is going to result, that's going to mean I'm going to move everything to the left just because that's habit. So I need to subtract 4 from both sides, and I need to add 5n to both sides. So what does that give me? 3n squared is not impacted. 6n plus 5n is 11n. And then there is no constant term over here, so just 0 minus 4 is negative 4. All right. So I have 3n squared plus 11n minus 4 is equal to 0, and I'm asked to solve it. Well, this factors. You can do this with the bottoms up method. You can do this in a whole bunch of ways, but this factors into 3n and n. Leading coefficient is prime, so I can get these with ease. 3, it's got to be 3n and n. The last two multiply to 4, and not just any 4, a negative 4. So that means these two numbers are either 2 and 2 or 1 and 4. And my operation in the binomials is addition and subtraction. So which case do you think it is? Well, if this is 2 times 2, I need to get two things that add to positive 11. And one of them has to be negative, one has to be positive. So if I put a 2 here and a 2 here, I'm never going to get to 11. So it's probably 4 and 1. So I need the 4 over here, so that 4 times 3 is going to give me 12, and then I'm going to take away 1, that's going to leave me 11. So that's a plus and that's a minus. This is the place I want to get to, because now by the zero product property, two factors have multiplied to give me 0, which means that the first is 0 or the second is 0. And now it's linear equations, right? So get n by itself, add 1 to both sides. 3n is equal to 1. Get n by itself, divide by 3, divide by 3. N is 1/3. Or subtract 4, subtract 4. N is negative 4. So my solution set contains two answers, negative 4 and positive 1/3. Okay, I'm doing the notation and being pretty specific here about how I write the solutions, because in the book, the answers in the back follow this form. They give you a they give you a set with the solutions in it. They don't just say n equals 1/3 and n equals negative 4. All right. So that's the zero product principle. It's probably the most common one that you use. Factor a quadratic so that it becomes two binomials, or just any two factors that are multiplied by each other. Get the other side to be 0, and then I have two things that multiply to 0, so one of them has to be 0. All right. So that is zero product principle. That's the zero product principle. The other, or one of the other steps, is the square root method. Okay, so get the equation in the form x squared, and x is just the variable here, equals k, where k is a real number. Take the square root of both sides. Well, I'm almost done there, right? I've already got it in the right form. Take the square root of both sides. But here's the piece you have to remember. When I take the square root of p squared, that's just p. When I take the square root of 18, because 18 is a real number, I have to consider positive and negative solutions. Okay, so think about that for a second. Just come over here to the side and think for a second. The square root of 9, that's not just 3, is it? 3 times 3 is 9, but negative 3 times negative 3 is also 9. So if I take the square root of a real number, I have to consider both the positive and the negative answers. And that's what that second line there. Remember, the solutions will be positive and negative k. So what have I got? I now have my variable p is equal to positive and negative square root of 18. And we're going to refresh you on breaking up your roots. 18. Can this break down into, does it have any factors that are perfect squares? So perfect squares, we don't count 1 for this one, but 4, 9, 16, 25, all the way up. This has a 9 in it, right? That's 2 times 9. Well, the properties of squares say that if I have two things under the root multiplied by each other, I can rewrite them as products of the roots of each. Square root of 9 is 3. And whenever you're dealing with roots or with radical numbers, always bring whole numbers or bring integers out front. Don't put them back here, because it's really easy to think that that line carries over and that 3 is still under the root. So the square root of 9 is 3. I brought it out front. There are the solutions. So what does my solution set look like? It contains both of those numbers. I've got 3 times the square root of 2 and negative 3 times the square root of 2. Thoughts? Okay, still feeling pretty, feels like something you've seen before. That's what we want. How about this next one? How about the next problem? I got 3y plus 4 quantity squared equals 16. This doesn't look like the problem before, but it is just like the problem before. I already have something squared is equal to a real number. So I'm going to do the same first step that I did up here. I want the y to get out. The y is currently in the parentheses and being squared. I cannot do anything until I get this y out of the parentheses. So I need to get it out. How do I get rid of a square? Take square root. If I do it on the left, I have to do it on the right. 16 is a real number, so I got to do positive and negative. The square root of a square is just the radicand, which is what's under the radical. Square root of 16 is 4, and then I have a plus minus over here. Now, to write your answer, this is kind of your own personal feelings or your own personal touch. At this point, you want to solve for y, you're going to subtract 4 and then divide by 3. Subtracting 4 and dividing by 3 while you have a number that has a sign with it can be confusing. So what I have here is essentially 2 answers. So I would go ahead and break this up into 3y plus 4 equals 4, and 3y plus 4 equals negative 4. Is everybody cool with that? Everybody good with what I just did? This has 2 solutions. One is the case where I have 4 on the right. One is the case where I have negative 4 on the right. All right. So get y by itself. Subtract 4 from both sides. And then get y completely by itself. 3y is currently equal to 0. I need the 3 to go away. And what I do, I divide by 3. 0 divided by 3 is 0. Okay. And my other solution. Okay, if you're trying to knock that rust off still, solving that linear equation, I want to get y by itself. So that means everything that has a y to one side, everything without to the other. 4 minus 4 is 0. Negative 4 minus 4 more is negative 8. And then I've got everything with the y is on the left, everything without is on the right. Now I just need y to be completely by itself. Divide both sides by whatever the coefficient of y is. In this case, it's 3. I have y is equal to negative 8/3. So my solution set contains 0 and negative 8/3. Whoa, that was just an unmitigated disaster of a Sorry, that's not much better, but and there they are. There are my solutions. Okay, so that's how to use factoring and the zero product principle, and how to use the square root principle. Most of the time, we don't actually write out the zero product principle. We just call this factoring, but you're doing two steps there. You're factoring it so that you get two things multiplied together and give you zero, then use zero product rule to solve the problem. So factoring and zero product are kind of going hand in hand. The square root is when you can get your variable or some algebraic expression squared is equal to a real number, and then go about your ways of taking the square root of both sides or whatever root you need. The other way to do this is the sledgehammer. Okay, here is the sledgehammer. It's the quadratic formula. Why am I calling it a sledgehammer? Because when you have a hammer, and that's the only tool you have, everything looks like a nail. This will always, 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 always give you the right answer. There are some cases where this is the only way to find the factors of a trinomial, or to find of a quadratic equation. And it comes down to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. For years, when I wrote this out, I didn't pay attention to that x equals on the left-hand side. So this is saying x is equal to the answer. So whatever I get after I do this work are going to be the values of x that make this equation true. The values of x that make this equation true are called zeros, because when I plug them in, I know that I'm going to get 0. So in order to use the quadratic formula, the first step is you have to be in this form. You have to be in it's called the general form for the quadratic equation, or for quadratic equations. Ax squared plus bx plus c equals 0. Everything is on one side, everything without is on the other. This is the opposite process, or if you're using quadratic formula, this is not how we solve linear equations. We just did some linear equations where I get everything with the variable on one side, everything without on the other, and then go. Not here. So let's tackle it. Let's come over here to the top right and solve x times quantity, x minus 6, closed quantity is equal to 3. This feels like it's easy, right? And this is where that zero product principle can get you in trouble if you're not careful, because it looks like two things multiply to give me 3. One of them's 3. That's not guaranteed. That only works when I have a 0 over here. So let's distribute x squared minus x is equal to 3. So I've got x squared minus 6x. I'm getting everything on one side. So I'm going to subtract 3 from both sides. Everybody good? That looks disturbingly like an equal sign. Fix that. All right, so this does not factor because there are not two numbers that multiply to -3 and add to -6. At least there's not any integers that do that. I can't make this a square root issue, and this is in the part of the notes where I say use the quadratic formula, so we're going to use the quadratic formula. So a is the coefficient of x squared, that is 1. B is the coefficient of x, the sign goes with it, that is -6. And c is the coefficient, is the constant term, which is -3. Why did the negatives come with us? Take a look at that general form again. What's the operation between each term? It's always plus, right? So if that's always supposed to be plus, this needs to be written as plus -6x plus -3. So that's why the negatives come with the a, b, and c if they exist. Okay, so let's plug in. So x is equal to the opposite of b, plus or minus the square root of b squared minus 4ac. all divided by 2a. And what do I have? b is -6. So that's -6 plus or minus -6 squared minus 4 times 1 times -3, all divided by 2 times 1. Everybody okay with that process? No mistakes found? Everybody looks like I'm doing my math right? All right, let's keep going. -6 is 6, plus or minus the square root of whatever you get here. This is b squared. Whatever the number is for b, positive or negative, the square is always going to result in a positive number, right? -6 squared is 36, positive 6 squared is 36. So this first term under the radical is always going to be positive. And now I have minus 4 is 1 times -3 is minus -12, all divided by 2. I can obviously clean that up some more. Minus negative becomes plus. And then can I go further? Yeah. Square root of 48. Any perfect squares in there? Absolutely. If you don't see any perfect squares, or if you don't think of any, try taking 2 out and then take it out again. And then take it out again and again if you can. Turns out 48 breaks down into 16 times 3. The square root of 16 is 4. And then all 3 terms that are left have a 2 in it, right? That 6 is divisible by 2, this 4 is divisible by 2, and this 2 is obviously divisible by 2. So I'm going to factor out the 2 in the numerator. That's going to leave me 3 plus or minus 2 root 3 divided by 2. Why did that help? Because I got rid of some more 2's. So what do I have now? I have x is equal to 3 plus or minus 2 root 3. So my solutions are 3 plus 2 root 3, 3 minus 2 root 3. Any questions? Oh, you can't see the bottom of the screen. All the way to the right. Questions on this one? All right. Well, let's take the last few minutes of class. Let's finish this page. And then we'll see what to do next. All right, so up here on the top left, everyone's worst nightmare just came true. Our fractions into this, okay? You can plug those into the quadratic equation and you will get the right answer. But I want to use, I don't want to work harder, I want to work smarter. So what can I do to get rid of these fractions other than beyond just not doing the problem? How did I get rid of fractions earlier? How did I get rid of fractions just a bit ago? Multiply. That's exactly right. What did I multiply by? Multiply both sides by the least common denominator, right? Yep, Andrew's got it. It's 10, right? So the smallest number that all three denominators go into, 2, 5, and 10, they all go into 10. Multiply left and right by 10. What's going to happen? I'm going to do this all in one step. 10 times 3/10 x squared is just leaves me 3x squared. 10 times 2 is 20. 20 divided by 5 is 4x. And then 10 times 1 is 10 divided by 2 is 5 minus 5. 0 times 10 is 0. Well, now that's much better, right? So I have 3x squared minus 4x minus 5 is equal to 0, and I'm going to use the quadratic formula. Now, when I write the quadratic equation, or the quadratic formula out, you'll usually say the opposite of b instead of negative b. So in this case, b is negative 4, so minus 4 is 4. So that's why you just see me going ahead and writing 4 plus or minus the square root of b squared, 3 squared is 9, minus 4 times a times c, all divided by 2a. And then let's work our way down. 4 plus or minus the square root. 5 times 4 is 20, or negative 5 times 4 is negative 20. Negative 20 times 3 is negative 60. No. Yeah, negative 60. And plus 9, or 9 minus that, how's that going to work out? It's going to look like a mess is what it's going to look like. Okay. Ooh, what did I do? Oh, I made a mistake. No, I did. Look at what I did wrong. I squared A instead of squaring B. Maybe I shouldn't jump to so many conclusions. All right, let's try. Let me get this right. Negative 4 squared. And we write it the right way. So that's going to be 16. And that's going to be minus negative 60, which is going to be plus 60, divided by 6. And 4 plus or minus the square root of 76 divided by 6. Does 76 break down into prime factors? Yes, it does. Or does it have a perfect square as a factor? It does. How did I find it? Is I just divided by 2 and divided by 2 again, and it worked. So what I found was that 76 is the same thing as 4 times 19. And then cut that off. Square root of 4 is 2. All the terms have a factor of 2 in it. 2 plus or minus root 19 over 6, which becomes 2 plus or minus root 19 over 3. So solutions. Two plus root 19 over 3, 2 minus root 19 all over 3. All right, so we'll call it there. That'll be the day, because it's time, obviously. Any questions? Anybody got anything that's bugging them? as behind as it feels, but I'm going to work really hard on getting us back up to speed. So end of last class, we started dealing with section R5, which is using the quadratic formula, or solving with the quadratic formula. And we see it listed here. And now we just got some practice problems to do here. I want to walk through a couple of these. So this is our work from last time. Let's take a look at where we're starting here. 2 problems. Each problem deals with the process I want you to use. So let's dive in. And the one on the left looks easy, so I'm just going to do one of each, and then like I did with the videos, I'll do the other for completion later. What I'd like to do is take a look. R1, R2 assignments, and Alex, yes. Yeah, if you complete those objectives, that will add anything that adds pieces to your pie is absolutely something we want to do if you're looking for that extra credit at the end. All right, so I'm going to tackle the problem on the right here, 3x squared equals 12x. The reason I'm doing it is it looks easy. So I'm dealing with a quadratic, even though I don't have a constant term. I want to get everything to the same side, so I'm going to subtract 12x from both sides. And then that leaves me 3x squared minus 12x. Here's our first habit that we tend to forget. If there are common factors, we need to take them out. If you have a trinomial and all 3 terms have the same factor, you need to factor it out. This one's even easier because there's only 2 terms. They both have an x in it, and they both have a factor of 3. So I can factor out 3x. And that's going to leave me, what? Well, 3x squared divided by 3x. It's just going to leave me an x. And then negative 12x, factor out 3x. It's going to leave me a negative 4. And look at that. I'm already to my step of by the 0 product principle. Things multiply to give me 0, so one of them must be 0. So either 3x is 0 or x minus 4 is 0. If 3x is equal to 0, don't freak out when you get something and you're like, wait a second, I don't know exactly how to do that. Follow the rules. I have 3x equal to 0. I want x by itself. That means I need to divide both sides by 3. 0 divided by 3 is 0. X minus 4 is equal to 0. I want x by itself. To get rid of the subtract 4, I need to add 4. And I now have x is equal to 4. So my solution set contains 0 and 4. We don't need to check our answers yet. You're more than welcome to. If you plug in 0 for x on both sides go to 0. If you plug in 4 on both sides, you're going to get 48 equals 48. So they both check. But there is our solution. Okay. So as I said, the vocabulary is important. This step, and if I come over here to the right, up top. All right, Andrew, and I've got, where's my mouse? Here we go. All right, Hannah, I've got your message here. Let me deal with that. I'll catch you after for that. But we'll make it work. We're gonna make it where you'll be able to take the test. We'll just have to figure something out. All right. So let me just jump over here really quick. I know I said I was only going to do one of these, but I do want to show you. If I'm dealing with a quadratic, and a quadratic just means my leading coefficient is non-zero, and it corresponds to the squared term. So this is a quadratic equation. If I want to factor, which is one of the 3 methods I'm using, I'm going to factor and then use the 0 product principle. First thing I have to do is everything has to be on the same side. So that means I'm going to subtract 24 from both sides, getting me a 0 on the right-hand side. Because remember, the goal is If I can get two things multiplied to give me 0, I can use the zero product principle. A lot of times people will forget there's two sides, or they'll forget to make that move. And it's kind of like playing a sport and forgetting that to win the game, you have to score a goal. You have to get points, right? You can be really good at passing, really good at dribbling, really good at defense and all those things, but if you can't put points on the board, it doesn't matter. We lose sight of what's the goal. The goal here is to get two things multiplied to give me 0 so I can break it up. This one is easy. The one on the left it's relatively easy. Two numbers that multiply to negative 24 and add to 5, in and in. They multiplied to a negative, so that means I know they're plus minus, and one's negative, one's positive. And then my middle term, the middle term is positive, so that means my positive number has the larger magnitude. And now I have two things to multiply. So again, this is by the zero product principle. I have two things multiplied to give me 0. One of them is 0. N is negative 8. N is 3. So then my solution set contains negative 8 and 3. Here's the frustrating part about math. This step right here is called factored, right? I factored that. This step right here is called factored as well. So in one case, we have to break out reverse FOIL. We have to take a trinomial, break it down to two binomials. On the right, I have a trinomial, but it only has two. I have a quadratic, but it only has two terms, so it's a binomial. And then I factor out a common factor, and now I'm left with two things multiplied to give me 0. So understand that solving can be, or factored, there are a lot of words in math that can be overloaded, like the word cancel, which I've talked about before, where it means the different things going on, but the goal is to reach that step. So I could say two things are multiplied to give me 0, break it up. One is 0, the other is 0. Okay. Okay, same thing. All right, so yeah, let me look into that testing question. I'm glad they're coming up now and not when our first test comes up. But yeah, let me look into that, and because that's the second person that has sent that message. So yes, I will figure something out. All right, so the top one is using factoring and getting the zero product principle to work for us. The second method is the square root method on the left. X squared is equal to 81. I'd like x to be by itself. Well, I can do that. That's easy. Yeah, just take the square and square root it. Just take the square root, right? Take the square root of that, take the square root of that. Well, here's the trick. If I take the square root of a real positive number, I have to consider the case that both the positive and the negative answers are there. So the square root of x squared just leaves me x. But on the right, it's plus or minus 9. So my solution set contains negative 9 and 9. How does this problem work the same way? Well, it's something squared equals a number. So I want to get this z plus 11 all squared on a side by itself, just like I did over here where the x squared was on the side by itself. So I'm going to add 10 to both sides. So that's 3 times z plus 11 squared is equal to 120. The square is not by itself yet. It's still multiplied by 3, so I'm going to divide by 3. And I now have z plus 11 squared is equal to 40. And now this problem looks like the problem on the left. Now, this is one of those cases where, yes, you have to kind of squint your eyes and look at it sideways and kind of look like a confused dog, but this is something squared equals a positive number, right? Just like this is something squared equals a positive number. So follow the same process. If I'm going to if I'm going to do something from here, what am I going to do? I'm going to do the same thing I did over there and take the square root of both sides. Square root. I've taken the square root of a positive real number. So I need to consider the plus and minus. What absolute value? That's a great question. If we did, so we wouldn't want to solve. So the question was, would absolute value do the same thing for us? You're not going to get at the end, since it means the distance from zero, right? But at the end of a problem, you don't want to have your variables equal to the absolute value of a number. You want to be able to break down or list all of the possible values. So we wouldn't want to have the absolute value of a number as an answer if we can avoid it, at least for these steps. All right. I know it's not a very satisfying answer, but that's it for here. We're going to get into absolute values in just a bit. So take the square root of both sides. Quantity z plus 11 all squared. Take square root as you get z plus 11. On the right, I get plus or minus the square root of 40. So what do I do with that? Well, I still don't have the variable by itself yet. Right? So I need to subtract 11 and subtract 11 from both sides, which means I'm going to give myself just a little bit more space. And just scooch it down, scooch. And what have I got now? I now have z is equal to, and this is just the way I'm going to write it, negative 11 plus or minus the square root of 40. Okay. You could also write plus or minus square root of 40 minus 11, but whenever we write irrational numbers, or we write a number where it has a real part and a irrational part, we usually write the real part first, the irrational part second. So my solutions break down into what? Well, the square root of 40, can I simplify that? Does it have any perfect squares in it? Absolutely. Negative 11 plus or minus. This is 10 times 4, right? And square root of 4 is 2. So this is negative 11 plus or minus 2 times the square root of 10. I'm making sure I didn't miss something, because I didn't. Now, how do I write this in a solution set? Okay, well, that's two different numbers, right? So there's my, so my solution set looks like what? Well, it's negative 11 plus 2 square roots of 10, negative 11 minus 2 square roots of 10. All right. Oh, come on, just scooch. Just scooch. Okay. Now, last one. Let's deal with the, let's do the problem on the left, and then I'll leave this n squared to do on a video later. X squared minus 3x minus 7 equals 0. Does this factor? So I need two numbers that multiply to negative 7 and add to negative 3. Remember, we're only interested in integers here. I don't want fractions or any of that mess. So multiply to 7. Don't worry about the sign for a second. There's only one way to multiply to 7, and that's 7 times 1. So is there any way where I can manipulate 7 and 1 with signs so that 7 plus 1, 7 minus 1, negative 7 plus 1, there's no way to make that equal negative 3, right? So that tells me this does not factor. So if it doesn't factor, I'm going to bust out quadratic equation. Quadratic equation says that I'm dealing with, my roots are the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. Make sure anytime you're dealing with this quadratic that you have everything on one side, because remember, a is the coefficient of the square term, b is the coefficient of the first power, c is the constant, but only in general form, ax squared plus bx plus c equals 0. take a glance down here at the one on the bottom. If you put C as -3, the answer will come out wrong. So you have to get everything to one side, then find your A, B, and C, and then plug in. So that's -3, which is 3, plus or minus the square root. -3 squared is 9, plus 4 times 1 times -7, all divided by 2 times 1. And what am I going to find? That's going to be 3 plus or minus the square root 9. And not my strongest start. B squared minus 4AC. I know somebody was thinking that. I had actually changed the sign in my head to handle this step. So it's going to be 9. This is -28. Minus -28 becomes plus 28. All divided by 2. Whoa, come back. 9 plus 28 is 37. 37 doesn't do anything fun. 37 is prime. Can't multiply to get it, so there's no way there's a perfect square in here. So this means my solution set, that actually looks like a face. Yeah. That means my solution set are these two numbers, 3 plus square root of 37 over 2, 3 minus the square root of 37 over 2. All right, so when you're doing a problem like this, don't let that plus minus get away from you, because if you do, you'll miss half the answers. All right, so that was just that quick refresher. Factor and use the zero product principle. Get it into something with the variable is squared equal to a real number or equal to a number, and then take square root of both sides. Typically, we would like positive numbers there, but we're going to get into complex numbers in just a bit. And then last, quadratic formula. All right. Now, is there another way to do this? Of course there is. What is that other way? Well, it's called completing the square. So let's bring the next page up. And let's talk about completing the square. So here's what's going on. I remember learning this. I was not a fan of this method for the longest time. And because it was called completing the square and I didn't understand what it meant. So what we have is, if you have a quadratic written in this standard form, ax squared plus bx plus c equals 0, like we have here, once I've done that and once all the common factors are divided away, that's not listed here, but we definitely want to do that. If there's any common factors, we'd like to divide them out. The first step I'm going to do is divide both sides by a, I'm going to take care of that with this division. Divide both sides by a leading coefficient, because it makes the leading coefficient 1. All right. Second step, isolate the variable, terms on one side, complete the square. What does that step mean? That means add the square of 1/2 of the linear term coefficient to both sides, and then factor, resulting in a perfect square trinomial, and then lastly apply the square root property. So when we factor to solve, we use the zero product principle, right? So that's kind of working the same thing. Completing the square is just getting us to a place where we can apply the square root property. So these are methods that are getting us to the point so we can use some of the properties we already know. So let's talk through what's going on, what I just said, because I know there were a lot of words there. Step 1. Step 1, wow, I misspelled step. It is, I don't even know what day it is, but it is early in the week. Step 1, I've got 2x squared plus 20x minus 6 is equal to 0. I am told to divide by the leading coefficient. Yes, all these have a factor of 2 in it already, so you could divide that out, but I just want you to get used to the process. Here, divide 10x minus 3 is equal to 0. Now, do we agree this doesn't factor? Yeah, right. There's no way two things multiply to -3 and add to -10. So I've done step 1. Step 2, isolate the variable terms on one side of the variable terms means terms that have a factor of a variable in it. So the x squared has a variable in it, the -10x. I swear I keep doing that. Thank you, Andrew. I don't know why it went minus. It just did. But still it does, even though that sign changed, I can't multiply to -3 and add to 10. My factors aren't large enough. Thank you. So isolate the variable terms and the coefficient terms. So what that means is everything with a variable stays on one side, everything without goes to the other side. So what do I have now? I have x squared plus 10x is equal to 3. Now, here's this part, here's that part of complete the square. Let me show you what's happening. Okay, when I say complete the square, what do I mean? I mean that I have on the left-hand side 2 of the 3 terms that would make a perfect square. Why do I keep saying perfect square or square? Well, the reason is this line is just not going to work with me today. So we're going to pretend I can draw straight lines here with my hands. All right, so this is what's going on. We have on the left-hand side, I have x squared and 10x. So that means I know that if I have my square, that whole big thing, pretend like that is the square, I know that I have x squared, which is x times x. And I don't know what these are, but I do know they have to add to 10x. It's a perfect square. They both break into 5x and 5x. So there's x squared plus 10x. And what we're saying is, if you get me leading coefficient of 1 with a square term, and then plus the single power term with the coefficient, I have 3 of the 4 blocks of a perfect square. Okay? The only way that this box has an area of 5x is if this is x and this is 5. The only way this has an area of 5x is if this is x and this is 5. So what do I need to finish off that perfect square? This length times this length, 5 times 5, which is 25. That's what it means to complete this square. So you'll see on the next step, what we're told to do is to take half of the coefficient b. So that means take 10 divided by 2 and then square it. Now, I can't just go adding things whenever I want, wherever I want, however I want. I have to follow some rules, and those rules are cut b in half and square it. But if I do it to the left side, I have to do it to the right side as well. Plus half of b squared. What does that result in? Well, I just showed you in the box over there. 10 divided by 2 is 5. 5 squared is 25. Plus 10x plus 25 is equal to 3 plus 25. Now, why did we do it? Why did we do this complete the square? Because every time we do it, the trinomial on the left is a perfect square. What is it? X plus 5 times x plus 5 every time. Well, it's not x plus 5 every time, but the factors, this always factors down into a perfect square trinomial. All right, or a perfect square. Now, this looks like something we've done. Now this looks like a problem from before, where I have x, something with x in it squared, is equal to a real number. I want to solve this for x, so I need to take the square root of both sides. That square root should extend over the square. Quantity x plus 5 squared, then take the square root. I'm only dealing with x plus 5. But on the right, it's plus or minus the square root of 28. Does 28 have a perfect square in it? Yes, it does. 28 is 4 times 7. 4 times 7, factor, so the square root of 4 is 2. So this is plus or minus 2 times the square root of 7. And then finish it up, subtract 5, subtract 5. And what do I have? We have x is equal to negative 5 plus or minus 2 square roots of 7. What's my solution set look like? My solution set has negative 5 plus 2 root 7s, negative 5 minus 2 root 7s. And that's supposed to be a curly brace. So there are my solutions. All right. Practice is absolutely going to be, with quadratic, you got positive 5. I've got negative on both. Let's see. Where did that go? B is negative 20. Oh, because you didn't factor out the common factor. Yeah, so even if you're going to do this with the quadratic, you would still factor out the 2 and divide it away. So your A would still be 1, your B would be 10, and your C would be negative 3. What it should do is you should have an answer that just has 2's that you can divide away in both. So this will come out to 10 and 4. And then you got a 2 you can factor out. You'd end up with these. I'm getting negative 5, and what I did in my work is showing negative 5 as well because this perfect square is x plus 5. And then I have to move that to the other side. That's why it becomes minus. Okay. All right. Questions? Ooh, that's a question. Does the lockdown browser? I'm not entirely sure which it does. I know it would limit access, so I think it just takes it away, but I don't think it closes the other tabs. Okay. All right, so yeah, let's deal with that. Let's deal with that outside of this. We'll keep working on our examples here. Any questions on the math here? I know Andrew, Andrew's put up his came out different with the using the quadratic equation, and I'm gonna leave that one out. Does anybody have any trouble here? Okay. So the idea is that what we said. If you put all the terms on the left that have variables, and on the right you got some number, some positive number. Sure, yes, absolutely, Andrew. You can keep using the quadratic. That is absolutely fine. Add number to both sides, move forward. Could we technically add any number to both sides? Sure, you can add anything you want to as long as you do it to both sides. But this is the one that's going to break it down so that you can then use the square root principle. 2 things. This is squared. I want to take the square root. I can do that if I do the square root to both sides. Yep. All right. So I'm going to leave this to be done on your own. Again, follow those steps, see what you can do. And let's get over to rational equations. All right. And again, I'll show you that skill practice question on a video after lecture today. What we have on this page is, I've got two examples. Get rid of the one on the right. It's the same problem twice. The notes originally said there are two ways to do this. I'm done with two ways to do this. We're just going to focus on one way to do these because I think it's the easiest. All right. So there are two ways to do it. You've seen them both. One of them is to make it so the numerator and denominator work out. The other is to clear fractions. And I'm always going to vote to clear fractions because students hate fractions. And you're more likely to do something that leads you to a path you like. So I have rational equations now. Rational, remember, rational expressions are where x is in the numerator or denominator, typically in the denominator. And now I've got rational equations because what have I done? I brought in equals. I've got an expression on the left. I've got an expression on the right. So I've got to solve these rational equations. How am I going to do it? Well, first step is going to be to find the LCD. So what is the LCD of my problem on the left? Well, first off, I have two rational expressions, and then I have one, which is just 1 over 1. So my denominators are 1x and 6x. And remember, the deal to get that LCD is any factor that repeats, I only count once. And then any remaining factors all get multiplied. So 6x and x have a common x in it. And then my middle term only has a 1 in it, which multiplied by 1, it leaves us with what we started with. And then the one that doesn't repeat is the 6. So my LCD is 6x. So I'm going to multiply both sides by. All right, so what does that do? That clears the fractions. So 6x times x plus 2 over 6x. The 6x is divide. I'm left with x plus 2. 6 times 1 is 6x. And then 6x times x minus 7 over x. The x's divide, and that leaves me with the 6 times x minus 7. Do the math on the right. On the left, combine like terms. X plus 6x is 7x's. On the right, distribute 6x minus 42. And now it's just a standard old linear equation at this point, right? Get everything with x on one side, everything without on the other. Subtract 6x from both sides, and then subtract 2 from both sides. What do I have? I have 7x minus 6x is x. Negative 42 minus 4 more is negative 44. All right. Now, something has happened in this process that means we need to start checking our answers. And that process is, I've got variables in the denominator. So look up at the original problem here. This isn't going to give you all the answers, but I want you to start thinking about this. If I look at this original problem, 7 minus x times 6, I would do it times 6 because the x and this x divide away. All right. There you go. Yeah, so take a look at this original. So x's are in the denominator, right? And division by 0. Division by 0 is bad, right? Division by 0 is not allowed because we don't know what it means. If we assign it some number, it breaks math. So if the denominators are not allowed to be 0, what are the denominators? Well, the denominators are 6x and x, right? So we can get out of this problem and we can come to the conclusion that if I end up with a solution of 0 and I plug it in to check, I'm going to divide by 0, right? That can happen in these problems now because x is sitting in the denominator. So because of that, I like to, when I start the problem, I'm just going to take a glance. Okay, this can't be 0, so x can't be 0. This can't be 0, so x can't be 0. So when I get to the end, if I get an answer and it causes division by 0 in the beginning, I can eliminate that answer off the bat. Negative 44 doesn't do that. So I'm going to check it anyway. Negative 44, and that's going to go into the original equation. So that's negative 44 plus 2. This is absolutely what a calculator is for, not something I expect to see by hand. Is equal to negative 44 minus 7 over negative 44. And what have I done? All right, negative 44 plus 2 is negative 42. 6 times negative 44 is negative 264. Negative 264. I said 4 and I wrote 5, and I don't know why. Plus 1 is equal to negative 44 minus 7 more. It's negative 51 over negative 44. Both of these are dividing negative by negative, so I can get rid of the negatives. And I'm just going to go straight to a calculator here, because I'm going to do this one step really quick because I want fractions on both sides. 1, I'm going to write as 264 over 264. And the reason for that is I would like to add the fractions on the left-hand side. 42 plus 264, 42 is 306. 306 over 264. 264 is equal to 51 over 44. Plug them into the calculator, and you're going to find out that 306 divided 264 is 1.15909090990, repeating. And on the right, 51 divided 44 is the exact same thing. You can also reduce 306 and 264 down to something over 44, but that checks. So my solution set contains just negative 44. So even though we've been dealing with quadratics at the beginning of R5, this one came out linear. I only have one solution. That's absolutely fine. All right. And if just so that I'm being, what's the word I'm looking for? Consistent with my answers. This is the solution set. That's why I've got the curly braces there, and it'll contain all of the solutions. How about the next one? The next one looks even worse. Okay. But here's the thing. I want to take care of this problem, and I want to find an LCD. The denominator on the right-hand side is a quadratic, and I could probably factor it. The numerator is a quadratic because my leading coefficient is with a variable of the second power, and that's the highest it gets. So I can actually clean this up a little bit. And what I mean by that is I can do some factoring before I try to find the LCD and then clear everything. So let's take a look at what we see. So 4c over c minus 5 minus 1 over c plus 1 is equal to, in the numerator, I have 3's, right? 3c squared plus 3. So I factor out the 3. That leaves me c squared plus 1. The denominator does what? Two numbers that multiply to negative 5 and add to negative 4. I've multiplied to a negative, so I know they are opposite signed. And then the middle term is negative, so I know that the negative is the one that gets the larger quantity. So the negative 5, the negative gets the larger quantity number of 5, and the positive gets the 1. All right, so what can I do with this? Okay, does this factor? Yes, it factored. Can I do anything on the right-hand side? And the answer is no, I can't. They're tempting you. They want you to say, oh, c squared plus 1, that's the sum of squares. That's not a thing. All right, we cannot break that into a pair of or two factors that are binomials. So as much as you want to, you can't. So what do I want to do next? Yes, that's exactly it. I want to clear the fraction. That is my goal. So I'm going to find the LCD. And the LCD is what? Well, factoring that denominator helped me see that I only have 2 unique factors in the denominator, right? I have c minus 5 and c plus 1. So if I multiply every term by c minus 5 over times c plus 1, all the denominators will multiply away, and I'll be left with what? Okay, well, I'm going to jot this in right here. No, I'm not. I'm going to be a good teacher. I'll write it again below because what we do. There we go. So let's write it out one more time and then show that multiplication off. I need the larger one just to be able to keep track of it. 4c over c minus 5 minus 1 over c plus 1. That's the left-hand side of the equation. And the right-hand side of the equation, c plus 1, c minus 5. And then both sides get multiplied by c minus 5 times c plus 1. And what happens? When I multiply the first term by c minus 5 times c plus 1, the c minus 5's divide, and that leaves me with 4c times c plus 1 minus, and if it helps, I can do the colors. The 4c was already there. The c plus 1 is what comes with. Next, the denominator is c plus 1, so the c plus 1's divide away, which means the only thing left is the c minus 5 equals. And on the right, the c minus 5 and the c plus 1 both divide away, just leaving me with 3 times c squared plus 1. Now, distribute on the left 4c times c plus 1, 4c times c, 4c squared, 4c times 1, 4c, and now this minus is distributed. Notice I put the c minus 5 in parentheses. That was so I made sure that I would distribute the subtraction to both terms. So that's minus c minus negative 5, which becomes plus 5. On the right, I'm going to multiply through, distribute that 3 back out. Factored it at the beginning just in case it gave me something I wanted, but it didn't. Before we go moving things around, add all like terms on the left-hand side, add all like terms on the right-hand side. What I mean by that is this 4c minus c is 3c. Do that before you start your process of solving the equation. And the reason is if you don't, there's a temptation to subtract one term on the right by multiple terms on the left. So now we've got that. I'm going to get everything on one side. So subtract 3c squared, subtract 3. Make sure I'm only doing it to the term that is like. 4c squared minus 3c squared is c squared plus 3c. 5 minus 3 is 2. And now does this factor? Two things that multiply to 2 and add to 3? Absolutely. C plus 2 and c plus 1. And look at that. All that work to get us to the zero product principle, two things multiply to 0. So one of them is 0. And what is it? Well, it's either -2 or -1. Now, the original problem is 4c over c minus 5 minus 1 over c plus 1 is equal to 3c squared plus 3 over c squared minus 4c minus 5. Do either of these answers cause an issue with this problem? So if I'm starting at the beginning, this denominator is not allowed to be 0. So that means c minus 5 cannot be 0. I'm going to pretend, I'm going to act like this is just a regular old equal sign and say, all right, well, if c minus 5 can't be 0, add 5 to both sides, c is not allowed to be positive 5. On the other factor I have is c plus 1. Well, c plus 1 is not allowed to be 0 either, which means c is not allowed to be -1. Does that appear? Yes, it does. If I plug in -1, I'm going to end up with something that doesn't make sense. So I have to toss that answer. So when I get done with this, what I'm going to find is that my solution set only contains -2. It does not contain -1. Because somewhere in this process, we have done something, we have divided by 0 or opened the door up for that, and it has led us to what's called an extraneous solution. N-E-O-U-S solution. Okay? Extraneous solution. So we have to eliminate that. And when you're dealing with rational equations, the issue is typically going to be 1 leads to division by 0. Okay? So there's my solution set. Questions? Does this feel like we've seen before? Are we really starting to try to knock that rust loose on the math that you've seen? All right. So the next page of the notes is just more practice. These are, again, problems that I'm going to complete in a video and post them because these have the exact same structure as the ones before. Yes. Hang on, let me go back. For 4c squared, thought it was 4c squared minus 3c squared leaves me 1c squared. So I can't put those together. What did you say was a strange solution? The -1. Oh, so the -1 is an extraneous solution because I did math, I followed the rules, and when I get to the end, the equation that I end with says that the solutions of this equation being c squared plus 3c plus 2 equals 0, the solutions to this are -2 and -1. That is correct. That's completely correct. But this is not the problem I started with. The problem I started with is this rational equation. I started with 4c over c minus 5 minus 1 over c plus 1 is equal to 3c squared over 3 all divided by c squared minus 4c minus 5. So while -1 is a solution to c squared plus 3c plus 2, I'm actually interested in the solutions to this equation. Yep. All right, so that's what makes it an extraneous solution. When I get to the end of the problem, it appears to be a solution, but when I go back to the original and plug it in, it does not work. So in this case, c is equal to -1 or just -1 is called an extraneous solution. There are equations where you only get extraneous solutions and the equation actually has no solution. Okay, so for instance, in this one, if I had found my answers to be 5 and -1. 5 and -1 both lead to division by 0, which means this equation has no solution. All right, so those are the extraneous solutions. Like I said, the next page is just more practice. And then the last page is even more practice, as I've labeled. But I do want to take a look at that even more real quick, because it looks like a short problem and it's not that bad, but I do want to talk about it. All right, so what about solve this? Wow, well, there's only 2 terms here. This is going to be super easy, right? 5 over x is equal to 2x over 3. Solve. Please, 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 I know you want to, do not cross multiply. That is the one thing that throughout my 12 years teaching math or 13 years teaching math, everybody remembers cross multiplication. Fight the urge. I know it's hard, but fight it. So here's how we're going to handle this. I have rational equation, right? I've got fraction and a fraction, and x is in a denominator. What's the LCD? Well, this has a 3 in it. This has an x in it. The LCD is 3x. So I want to clear fractions, and that's what I'm going to do. Came here to take names and clear fractions. It's terrible. All right. And then multiply both sides by the LCD. What does that do? Now I have 3x times 5 is 15x. 15 divided by x is 15. And then on the right, 3's divide, leaving me with 2x squared. All right. Now, I have 2 terms of a trinomial, of a second-degree polynomial, and our quadratic. I'm going to use all the words I can. And this looks like one of the forms. I have x squared. Now, before I had a term of x squared and a term that had x in it, I put them both on the same side, factored out the x, and used the zero product principle. That's not going to work here because I have one term that has x squared in it and the other term is constant. This is almost a square root principle. All you gotta do is get that x squared by itself. Can we do that? Absolutely. I'm just going to divide both sides by 2. So just whenever you're trying to figure out what's the next step, or what do I do, or which one do I divide by? Do I divide by 2 or divide by 15? Always look at it and remember that whatever happens to the constant term is typically collateral damage. It's just the result of me trying to get x by itself. All right, so whatever happens over here that's all determined by what did I need to do on the right-hand side to get x by itself. And that's about to rear its head again because I need x to be by itself. I'm currently looking at x squared, so take the square root of both sides. I've got a real number on the left-hand side, it's a positive real number, so that means I need to consider both the positive and negative solution. So that means I'm looking at x is equal to positive and negative square root of 15 over 2. As frustrating as that looks, that is as simplified as this is going to get. So my solution set contains positive, no you cannot, no, 7.5, oh, for the inside, ooh. I wouldn't, and I'm going to show you why, because it's going to come down to when we check. So you're going to look at square root of 15 over 2. You could rationalize the denominator if you wanted to and end up with the square root of 30 over 2. Yeah, but again, it's going to come out real quick to why we did this. All right, so there's my solution set. Need to check them, and we already talked about if I'm going to run into problems with this, it's typically going to be division by 0. The original problem is just 5 over x is equal to 2x over 3. So I'm going to check root 15 over 2 and see what happens. So that's 5 over the square root of 15 over 2 is equal to 2 times root 15 over 2 divided by 3. Now, if you want to cross multiply, this is when it comes into play. You almost never, always going to qualify this, whenever I have variables left in this is called a proportion, when I have a fraction on the left and the right, anytime you got a proportion and it's got variables in it, you clear the fraction, you multiply by LCDs. Now I just have numbers, right? And the rule says, cross multiplication says, if A over B is equal to C over D, then A times D must equal B times C. All right, that's cross multiplication. So if A over B is equal to C over D, when I multiply diagonally, when I multiply across, I'm going to get two things that are equal. When I multiply this across, that's 5 times 3, which is 15. And then I get 2 times the square root of 15 over 2 times the square root of 15 over 2. So that's 2 times the square root of 15 over 2 times the square root of 15 over 2 over 2. Oh, question? All right, square root of 15 over 2 times square root of 15 over 2 is just 15 over 2, just like square root of 2 times square root of 2 is 2. I'm almost there. These 2's divide, and I'm left with 15 equals 15. That checks. Let me see. All right, where are we at, Tenny? So here's the original 5 over x. The 2x over 3. And then when I check the root 15 over 2, I just plug those in for x. So that got me this. And the cross multiplication says if I multiply the diagonals, then I'll get two things that are equal. I got two things that are equal, so that means this proportion is true, which means the square root of 15 over 2 is a solution. If I did the same thing with negative square root of 15 over 2, when I multiply across here, the negatives are going to multiply out to a positive. So this checks for both. So those solutions are correct. Okay. Any confusion? Go ahead and let you answer. I'll ask your question. Was there anything, any step in there, specific piece that was just both problematic? No? All right, you keep typing. I'm going to go on. Oh, here we go. Looks good. All right, you keep typing. We can come back to it. But I do want to finish up. So this is the first half of R5. We're going to get done with this today. We're going to get back on pace. It's just going to take some time. So when I have a formula or equation and I'm asked to solve for a specific variable, what do I do, right? You're used to dealing with equations where you have one variable and I solve and I get that variable. Or I have an equation that has multiple variables, but along the way, I'm going to be given A, B, and C, and I just need to find the variable. In this case, I don't. I just have the direction here to solve for C. C is over here on the right. It's currently being added to A and B. So I want to solve for C. Solve just means get it on a side by itself. All right? So everything with the C goes to one side. Everything without goes to the other. Well, this is the only term that has a C in it. So this is currently A plus B plus C. I want to get rid of the A, so I'm going to subtract it. So I'm left with P minus A is equal to B plus C. C is almost by itself. I just need to subtract that B. And now I'm left with C is equal to P minus A minus B. For the next one, now I've got powers, I got multiple variables, and they're multiplied this time, right? On the left, problem we did before, I was just subtracting things to get them to go away. That's not going to work over here. If I'm going to solve 1/3 pi r squared h for h, if I'm going to solve that for h, that means get h by itself First thing I'm going to do is get rid of that fraction. And I'm going to get rid of that fraction by multiplying by the LCD of both sides. What's the LCD of both sides? Well, there's only one denominator, and it's 3. Everything else has a denominator of 1. So I multiply both sides by 3. And now I'm looking at 3v is equal to pi r squared h. Okay? Pi r squared h. None of that is added. That is all multiplied. So to get rid of it, I need to do the opposite of multiplication, which is division. So I'm going to divide both sides by pi r squared. I do it to the left, I do it to the right, and I end up with what? On the right-hand side, I have h. On the left-hand side, I have 3v divided by pi r squared, and I'm done. Nothing divides on the left. All the variables are different or unlike, so there's nothing left to do. Again, not something you run into a ton. Typically, you're going to be given an equation and then told most of the variables, but I want you to handle this if you can. All right, next, same equation. The volume, this is the volume equation. The volume is equal to 1/3 pi r squared h, but we're told, and we were told this before, r is greater than 0. I'm solving this for r. All right, so same process. I'm going to multiply both sides by 3 to clear that fraction. And that's going to give me 3v is equal to pi r squared h. This is going to be almost identical as before. I want r by itself. So I'm just going to, it's pi r squared h. I'm going to divide by the pi, divide the h. And what do I have? I have 3v over pi h is equal to r squared. R is not by itself yet. Pi h is equal to r squared. I need to get r totally by itself. So that means I need to take the square root of the right-hand side. If I do it to one side, I do it to the other. And now this is where we get the question. Do I consider the positive and negative? Do I have to do the plus minus over here? The answer is no. And the reason I don't have to do the plus minus on the left is that I was told at the beginning, since r is greater than 0, only consider positive solutions. So that means r is equal to 3v over pi h. If I was not told that, I would need to consider whatever makes this positive, all the values that make this positive 3v over pi h, and all the values that make it negative 3v over pi h. All right. So last thing, I'm just going to talk this through and then we're going to go. The other half of R5 is radical and absolute value equations. And the way that they work is similar to what you've just seen.